Hey, yeah, welcome back to part 3. I already did explain this, but unfortunately, the audio was not on, my mic was not on. So, we'll quickly go through this again. We were at hub event processor. Now, based on the type of hub event, like merge message, revoke message, or prune message, it would go and call it the process message. That is what we had already seen. Now, in this there are four things that we need to keep an eye out for. One is a message processor, which calls store message. One is a store message operation. It is of four types, as you can see here: merge, delete, revoke, and prune. One is a message state, which is created or deleted, and one is the message handler, which is to be defined by the user for every event that comes in through the Redis stream. And this is basically what we discussed. So we can now get into message processor and start looking into it. Yeah. So moving to message processor, I think it's a straight call into store message. It takes the database. Store message operation by default is merge here. It takes in a logger and a validate. It imports a bunch of validations from Node.js, which we had also looked at. It checks in the protobuf, checks in the message type, then the message data body, and whichever relevant data body is present inside the message, and validates or invalidates it. In case where validate is true and operation is merge, you run a validation. If it throws an error, just log it and throw an error. No data, throw an error. Finally, convert the protobuf message body to JSON. We had seen this. This comes in from utils, and this is the function. Depending upon the type of message data, it has a bunch of logic inside it through switch case, and it converts the protobuf into the JSON object. Finally, op data, like some sort of metadata linked to the operation in the database that is happening here. If it's merge, do nothing. If it's delete, prune, or revoke, just add a timestamp. Now let's get into the crux of this entire operation by message processor dot store message. This TRX is like some sort of a database client that it is connecting to, database transactional context. Takes an FID, type, timestamp, hash scheme, signature scheme, hash, signer, the raw message encoded as I think probably bytes, and finally the body and the op data. It will return the ID, and on conflict it returns this particular piece of logic which I had asked ChatGPT about. Let's quickly get into it. Validation logic is fine. We have done this. Prepared data, done this. Op data. Insertion logic. Insert data, value specified, conflict handling. Specifies how to handle conflicts using on conflict method. It is set to update the existing records when there is a conflict on the hash, FID, and type columns. Set to update the existing records when there is a conflict on hash, FID, and type columns. Do update set specifies which fields to update in the event of a conflict. On conflict, of columns hash fid and type to update set. The signature is updated, signer is updated, the raw data of message is updated. Where EB or okay. I think a bit more clarity here is needed. Explain in greater depth the logic for resolving conflict. Exactly is EB. Update set fields to be updated if a conflict is detected. This ensures that existing record is updated with new values rather than rejecting the insert operation. Signature scheme of data. EBR specifies conditions under which update should occur. More granular control. State of the existing data versus incoming data. EB stands for expression builder. Okay, used to construct SQL-like conditions. OR combines multiple conditions using logical OR. Each condition inside the OR compares the state of an existing record versus the incoming record. Excluded or deleted at is not null. That particular row dot deleted is not null and messages dot deleted at is null. If deleted at was not set before but is set in the incoming message, indicating a new deletion state that should be updated. Excluded or deleted at is null, message or deleted is not null. Prune that, revoke that. For all these checks, if one of them has a timestamp. If one of them has a timestamp, then just update this piece. Signature, signer, the raw data, and opt data. That all is updated. If these three combined, identifying a message uniquely, conflict. It's not appending a new row, it's updating the existing row for these fields if there is a conflict detected on a combination of these rows, these columns. Okay, one thing I just want to confirm here is dot columns in the above case does dot columns of ID mean a combination of all three together or conflict in any single these columns. Ideally, I think it should be a combination. So even if hash is like, let's say, very low probability, but still same for different FIDs, it should work. Measure specified columns considered together to determine a conflict. Okay, it's a composite key, so it's taken together. So if a new message comes in, that is like once you insert a particular data or delete or prune or revoke something, if this is the same, that means that message was already present in the database, so you just do an update set on these fields if these fields are valid. Execute take first. Finally, what is the role of execute take first? Where return value, okay. What is the role of execute take first? It executes, retrieves the first result from the query set result. Alright. So you're returning ID, should return the ID of the inserted record. Conflict resolution, first result. Records ID. I think this is what it would be. Insert into values, return data on conflict where execute take first. And this converts it into a Boolean value. Straightforward implementation. Now message processor is also sorted. Can go back to hub event processor and see as to what exactly is happening there. Right, so here end if they are deleted messages whose length is greater than 0, deleted message dot map, deleted message is new. Await message processor dot store message, deleted message, transaction delete log. If that deleted message did not exist in the database, then this gets us is new, and then message state for deleted is new. One second, deleted message and delete. Deleted message and operation is delete. Operation equal to delete. Okay, is add is false. If is add is false, not is that, we'll just return deleted. fork. Let's say operation is centers. By default it's merge. Created a new one. Is new will be true. Merge and message. If I pass in merge and message, is that becomes true? Add message. Okay, created. For deleted also, I think the operation is going to be merge. Message processor. This is merge. Deleted messages. How do I get deleted messages? Still not clear. Event.merge message body dot deleted messages. Event is a hub event. Time to check in. Hub event. Hub Node.js. Where are you? Hiding hub event. Farcaster hub Node.js. Where is hub event? Okay, I could not find just the hub event, which is pretty weird. Alright, for now I'll just assume that it has this functionality available. Merge message body dot message, merge message body dot deleted messages. I need to check. Index. Hub event here as well. Hub event. Interface hub event, okay. Merge message body. Merge message body. That is fine. Merge message body dot deleted messages. Merge message body, encode decode from JSON to JSON from partial. Deleted messages dot map. Partial. Still not clear as to where it's coming from. Deleted messages. Message body has a message and has deleted messages. Partial create base. It's coming from somewhere else. Create base merge message body, message identifier deleted. Okay. This is just a wrapper around merge message body. What exactly are deleted messages is still unclear. Questions to ask is what exactly are event or deleted messages? Alright, for now we can just go back and assume that it's an array of messages with some event type is deleted. That is also coming as part of our event in another body. Revoke, prune and merge. Fundamentally it's using 3 types only, but where are these deleted messages coming from? Alright, this is fine. Going back to our event processor. Process message. Deleted messages dot length is greater than 0. I just asked ChatGPT once as well. Analyze the following code step by step. deleted messages or from someone missing is new await message or store message. Send it that particular message or delete. Great, how did I miss that? I'm stupid. Operation coming in as delete. So if I validate an operation equal to merge, this gets skipped. Body is converted. Delete. New date. Result. Insert into this. On conflict. If it's already deleted, compare on this. I think whatever event is coming in, they are being two parts. Somewhere upstream I'm missing this small point that apart from message, there is a bunch of deleted messages that are also appearing. Well, let's say if they found an ID, returning that gets converted into a boolean. So they found an ID for that delete message. So is new becomes true. Now state, this dot get message state, message that particular here, right, deleted message, and state here comes in as delete. So is new is actually true if they found that message to delete. Delete message and delete message and delete message. Operation equal to is that becomes false. Is that this is false or not is that okay? And is cast add message return deleted. Alright, state deleted, it's returned. Is add is link add message, reaction add message. Okay, which are the type is? It will return created or deleted on top of it. Fine. So it found the ID, it deleted it, and check the state. This was thrown as deleted. So is new is true, state is deleted. Handle message merge. Message transaction operation state is new becomes true, state becomes deleted, was missed is false by default. Now this is the piece of code that I think is not there, and we as a user need to implement it. Event processor. So we did event stream, we did hub, event processor, hub, subscriber, index, message processor, message reconciliation, and db.ts. These two are left. Let's quickly get into DB. Postgres, Camel, Slungin, Kisili, insert, okay, hash scheme, Farcaster hub, this is all done. Drain outer generate, simplifying result, cursor. This is just Postgres setup. Cast add body JSON. Get a bunch of types. Message body JSON, again just types. Message table. IDF ID transaction. What is data revoked at? Alright. So the same message, you can just update it. Message row, insertable message row, insertable, and takes a message table. Hub tables, messages table. Get DB client, set up the database, Postgres max 10, connection string, execute database, dbut, extends key of dbut, select all different queries, execute take first. Query.execute take first, just a wrapper around this with proper types. Execute take first or throw. Okay, execute transaction, wait callback on transaction, stream. For await constant row of query.stream, await function row. Give it a function, apply it Get estimate of tables row count. DB transaction. Okay, so this is basically Postgres setup. What is the one thing that we are missing? Now let's get into message reconciliation. This is the key part. Reconcile messages, type for FID. These are the message reconciliation pieces. Handler is not written here. Ensure that all messages for a given FID are present in the database. Can be used for both backfilling and reconciliation. How does this work? It takes an hub RPC client, a database, and a logger. Reconcile messages for FID. It takes an FID, an on hub message. Message missing in database. Pruned in database, revoked in database. Type of this is login for reconciling messages. Await this reconcile messages of type for FID. Okay. So whenever you want to reconcile, you give it the message and say missing in databases. Let's say true. Reconcile messages for type for FID. Message type on hub message. Worked in DB. This is a callback it's getting. Is an improve hub messages by hash. Messages of this dot all hub messages of type for FID. So it calls all hub messages of type for FID. Gets the message hashes. A message hashes dot length is 0. It will say no messages found. Then it gets all the DB messages. Select from messages. Select hash and message hashes. Not execute. Now using this, it generates key equal to buffer from message hash to string hex. Message hash converts into hex and use that as key. So it pulled in all the messages from the hub, pulled in all the messages from the database, created key for it, message hash key, hub messages by hash. Hub messages by hash. DB message hashes. So actually is equal to message. DB message equal to DB message hashes. Message hash key. Undefined, await on a message, true, false, false. Okay, then it calls on a message. That particular message missing in DB would be true, pruned and revoked is false. On hub message. Right, else was pruned is false. False, D message is pruned at, was pruned true, true. Then it was pruned and revoked. Great. The two things that I found for reconciling, it is there is a separate piece, message reconciliation. It is calling on hub message. After comparing hashes, messages in DB and hub. Private all messages are type for FID. Where does it call it? Cast at get all cast messages by FID in batches of reaction message link. Okay, different types defined for get all cast messages. The page size is I think 3000 FID for next page token result dot value. This dot client dot get. Oh, okay. Hubs have these methods. Yield messages page token or length. It's comparing from the hub. This is a more of a syntactical thing. I'll just quickly ask GPT. Batches of this is also straightforward, like message reconciliation 3000. I think this can be a process running every like 1 hour or something in the current state. Okay, we'll have to figure out how to improve upon this. Okay, message reconciliation is also sorted. Now let's quickly get into the example app and see what they are doing. db.ts, again just setting up a migrate to latest cast row and setting up a Postgres environment.ts hub host SSL Postgres total shard index Redis URL log worker, get into app, DB client, hub client, message handler, reconciliation. Alright, so it starts with all the environment variables, node process, node URL, get queue, get worker, two things: get queue and get worker. Queue from bool mq. Farcaster time to date. Hub ID is shuttle. It implements message handler, right? DB hub subscribers, stream consumer, Redis hub ID, constructor. Pass it all in. Static create function. It initializes it. Database hub, Redis, event stream for write, event stream for read. Two connections to be established. Shard key, if this is 0, all. Otherwise, shard index, hub subscriber. Shard index. Stream consumer. Stream consumer. Stream consumer. So in the app itself, we are creating it. It puts in all the values, then calls the constructor to initialize it. Handle, message, merge, reconcile, backfill, ensure migration, stop. Handle, message, merge. Message, database, storage, message, state. Message was already in the DB. No. To materialize casts into separate table. Insert casts into a separate table, mark them as deleted and removed. Note that since we are relying on state, this can sometimes be invoked twice. When cast remove is merged, this call will be invoked twice. Cast head, operation delete, state deleted, was removing, okay. Cast remove, operation merge, state deleted, okay. Is cast message, is cast remove message. Cast message and state is created and insert into casts. Handle, message, merge. Reconcile FIDs, parent database, reconciler, reconcile, missing DB, hub event processor, handle missing messages. Okay, it goes back to hub event processor. Max FID, FIDs are from length +1, backfill queue. Okay, these are the things that I need to look at properly in the example app. This is critical. But overall, the flow is pretty clear. The story starts at hubs, goes through these 3 classes, eventually goes into event stream, that puts it in Redis, and from there the hub event processor picks it up based on event type, calls this processor store message, and inside store message this is where write to PG, update row if conflict, on hash FID and type. Okay, in about an hour, I'll come back and finish up the example app, and then we'll try to implement this.